All right, welcome. I'm glad we're able to make it to this final episode. So now we're going to talk about scaling, right? We've talked about having the Cloudflare as a security layer for lots of things, right? And then we moved on to talk about how you can architect your middleware size of the backend layer, and then we proceeded to explain how you can upload directly to S3 bucket if you're using the AWS services, right? But now we need to talk about a rather more complicated, or I may believe it's an easy approach, anyways. But some people find it very complicated, right? So let's try to break it down, so it's a bit more understandable, right? So we're talking about scaling, right? And scaling, as you know, you can either horizontal scale or you can vertically scale. So when you're scaling horizontally, you're just stacking servers upon servers upon servers, right? Just instances of of servers and all of that. That's what you're doing. But vertical, you're basically increasing, trying to upgrade one server, right? Say for example, um, you're using an iPhone 14, you might want to upgrade to an iPhone 15, right? Something like that, right? But the way this works is that you're upgrading the server in terms of CPU as well as memory, right? We can increase that and say, okay, I was using two CPU earlier for my server. I want to have like eight CPU, right? The memory I have before were like 8 gigabyte, but now I need 16 gigabyte of memory. That's in a vertical, you're vertically scaling your server. Just remember, you're working on one single server, right? So, just to recap, I'm just going to explain a few things here, which I think are very important. We're going to cover the algorithms for load balancing in a few seconds, right? So, let's talk about the client's mobile, like we talked about. When you do direct upload, it goes to S3, like the way we have it, and all of that. So, we have a Cloudflare as our middleman to do the whole web application firewall, right? Really limiting and caching at the gateway level, at the top level. And then we have our own load balancing, right? So load balancing basically allows you to, as the name say, right, just balance loads, right? Any traffic coming to your server, load balancer basically helps you to balance those traffic so that your server is not overwhelmed, it doesn't crash, it doesn't run into timeout, right? So there are lots of different. I've explained the two different scale systems we have: vertical scaling and horizontal scaling. You can see horizontal scaling here. You're just stacking servers upon another, and vertical scaling, obviously, you're upgrading like more CPU, more RAM, and all of that. So I hope that helps. So now we want to talk about the algorithms for load balancing, right? And this is very relevant, especially to when you want to horizontal scale your application. And there are different algorithms out there. And the common one, which is what we use for the most part, is called the round robin algorithm. The round robin algorithm, what it basically does is that it it tracks the server to know the amount of load each of the server has, and tries to route a request to the server with least amount of load. So that way, for example, I have three servers, for example, and I make my first request. My first request will go to server one because it doesn't have any load or whatever, right? And I made a second request. Since my server one is still, it's still very much light, it doesn't contain more load, it goes to server one as well. So if, for example, I made a third request, and it happens that my server one is getting overloaded, right? What Robin algorithm would do is going to channel that request over to server two, right? And it channels it over to server two. You make like a third request, it goes over to server the fourth request, like that, right? So that's the way it basically like positions it based off the load that you have. It distributes it very accurately based of the amount of load. How that helps, right? So that's what a round robin algorithm does, right? So apart from this is the most common, and it's the depending on your use case, some people tend to use the least connections algorithm. So this one on the other end, as the name explains, least connect. So servers with least amount of connection will be prioritized, right? Say for example, you have server one and server two and server three, and it happens that server three is really busy, right? the least connection algorithm will either route to server 1 or server 2 and not server 3, because server 3 already has is blown up with lots of connection. So it's going to just take it to the least available server and route your request there. This kind of make it very your request, the availability time of your request, very good, right? So I hope that helps, right? So requests are sent to the server with the fewest active connections. Helps a load distribution based on your current usage. So the last one, which is IP hash, right? So this one is actually very useful for some use case, right? Especially when you want to have something called sticky sessions, just for persistence, right? So what happens is that every request coming from an IP, from a specific IP address, goes to a specific server. Say, for example, I'm making a request. I make a request to a server and server one, and this server one already recorded that, oh, my IP address is 192.168.1.11, for example. So if I'm making subsequent requests, right, it's going to know, the load balancer is going to know via this algorithm that, okay, I've already made my request to server one. It's going to make that same second request to server one again, right, without a new server. Right? It's going to continue like that. Say, for example, we have a new request coming from a different IP address. It's going to route it to a different server, say server 3, and subsequent request from that IP goes to server 3, right? So this IP hash algorithm basically allows you to do all of this to keep things sticky, right? So, for example, you're making requests and you run some background tasks and you want to persist, the functionality as much as possible. This is the way to go, right? So, might not be the most common approach, but yeah, people use it for the use cases, right? So, the most common one, just to recap, is the round robin algorithm, and we have the list connections algorithm, which is really cool as well, depending on how you want to use it for your use case. And then we have the IP hash algorithm. Right. And finally, before we wrap it up, we have something called the database cluster. Right. So now, the common notation is that you have a database, and you just make all your requests to the database. In the real world environment, that's not how that works. You have to create replicas, right? It clones, right? They called replicas. You create replicas of your DB to always allow for availability, right? So one DB might be getting overwhelmed and all of that, right? So what your replica does is that you could easily just channel some of those requests to replica, and that allows for availability, and also in case you want to back up and all of that, so they don't run into issues. So very cool stuff. And there's what they call database sharding and all of that. I believe later we'll discuss more about the complexities of all of those. But yeah, I believe I've been able to explain this concept to you guys in these, I think, 4, 5 episodes. Thank you guys, and I'll catch you on the next one.